In this question, we're asked to describe the single transformation that maps shape A onto shape B. So the first thing that we can see is that this transformation is a translation, because shape A and shape B are the same size and are in the same direction. Shape B has simply been moved from its original space to a different space. So we've identified that this is a translation, but we need to be able to identify the vector by which A has been translated. So we can do this by choosing a certain point. So looking at the same point on both shapes, we can see that to get from this point, which we'll call 1, to point 2, we need to move 1, 2, 3, 4 spaces to the right, and 1, 2, 3 spaces down. And so a vector that goes 4 spaces to the right and 3 spaces down can be written as 4 minus 3. And so we can say that the single transformation that maps shape A onto shape B is a translation by the vector 4 minus 3. And so the 2 marks in this question. The first mark is for identifying that it's a translation, and the second mark is for getting the correct vector of 4 minus 3. In this question, we're given a time series graph which shows information about the percentages of the people in a village that used the village shop for the years between 1980 and 2010. In part A, we're asked to describe the trend in the percentage of the people in the village who used the shop during this period. Now taking a look at our graph, we have a negative correlation, so we can see that as time goes on, the percentage of people that use the village shop decreases. And so in part A, we can say that the general trend is that the percentage of the people in the village who use the village shop decreases. Now in part B, we're asked to use the graph to predict the percentage of the people in the village likely to use the shop in the year 2020. And so to find the percentage in 2020, we can extend the line on our graph. And so after having extended the line up until the point that the year is equal to 2020, we can use this to find the percentage. And so drawing a horizontal line from this point, we can predict that the percentage of the people in the village likely to use the shop in the year 2020 is 14%. Now in the second part of part B, we're asked if our prediction is reliable. And the answer is that no, our prediction is not reliable, because 2020 is beyond the time period covered in the given data. We were given data from 1980 to 2010. Since 2020 does not fall within this range, our extrapolation is not actually reliable, and so we can write this down in our answer box below. This question is worth 4 marks, so let's take a look at where these marks are allocated. Now part A was worth 1 mark, and we get this mark for saying that the percentage of the people who use the village shop decreases. Now in part BI, we had to use our graph to predict the percentage of the people in the village likely to use the shop in the year 2020. And so 1 mark for part BI was for extending the line on our graph. And the second mark is for getting an answer in the range 13% to 17%. Now since our answer of 14% falls within this range, we're able to get the second mark for part BI. Now in part BII, we get 1 mark for saying that our prediction is not reliable because 2020 falls beyond the time period covered by the given data, allowing us to get the 4 marks needed to get full marks in this question. In this question, we're asked to expand and simplify 3 brackets y minus 2 plus 5 brackets 2y plus 1. And so let's start by simplifying the first term in the expression. 3 multiplied by y minus 2, we need to remember to multiply 3 by each term in the brackets, as the 3 multiplied by y is equal to 3y, and 3 multiplied by minus 2 is equal to minus 6. And then we have plus 5 multiplied by 2y plus 1, and doing the same thing again, 5 multiplied by 2y is equal to 10y, and 5 multiplied by plus 1 is equal to plus 5. And so then we have 3y minus 6 plus 10y plus 5. And so we can collect like terms. And so we can use colours to identify the like terms. 3y and plus 10y are both like terms because they're both terms of y. and then we have the constants minus 6 and plus 5. And so let's start with the y terms. 3y plus 10y is equal to 13y, and minus 6 plus 5 is equal to minus 1. And so the expanded version of 3 brackets y minus 2 plus 5 brackets 2y plus 1 is equal to 13y minus 1. Now in part B, we need to simplify 5u squared w to the power of 4 multiplied by 7u w cubed. Now an important index rule to know about is that a to the power of x multiplied by a to the power of y is the same as a to the power of x plus y. And so we can use this rule in our question. And so let's look at each term separately. 5 multiplied by 7 is equal to 35. And then we have u squared multiplied by u, and then we have w to the power of 4 multiplied by w to the power of 3. And so we can also say that u is the same as writing u to the power of 1. Now let's simplify this further. We have 35, and then u to the power of 2 multiplied by u to the power of 1 is the same as saying u to the power of 2 plus 1, which is the same as writing u to the power of 3. And then we have w to the power of 4 multiplied by w to the power of 3. Now this is equal to w to the power of 4 plus 3, and so we now have w to the power of 7. And so we can now see that 5u squared w to the power of 4 multiplied by 7u w cubed is equal to 35u to the power of 3 w to the power of 7. Now this question is worth 4 marks, so let's take a look at where these marks are allocated. Now in part A, the first mark was for the correct expansion of the brackets, so we have 3y minus 6 and we have 10y plus 5. And the second mark is for simplifying and getting a final answer of 13y minus 1. Now in part B, the first mark is for showing that 5 times 7 is 35, and then we have u to the power of 2 multiplied by u, and w to the power of 4 multiplied by w to the power of 3, in order to get the terms in our final answer. And now the second mark is for correctly multiplying and getting a final simplified answer of 35u cubed w to the power of 7, allowing us to get the 4 full marks needed for this question. In this question, we're given a regular octagon and a regular hexagon. We need to find the size of the angle marked x. Now given that we have a regular octagon and a regular hexagon, we can say that all of the interior angles in the octagon are equal and all of the interior angles in a hexagon are equal. Now the first thing that we need to do is to find these interior angles. Now the formula for finding the total interior angles of a regular polygon is equal to n minus 2 multiplied by 180, where n is the number of sides. And so for the octagon, n is equal to 8, and so n minus 2 multiplied by 180 is equal to 1080 degrees. And so if the total angles in a regular octagon add up to 1080 degrees, each angle is equal to 1080 divided by 8 angles, which is equal to 135 degrees. And so each interior angle of an octagon is equal to 135 degrees. And so we can label this angle as 135. Now let's do the same for the hexagon. And so using the formula n minus 2 times 180, we have 6 minus 2 multiplied by 180 degrees, which will give us an answer of 720 degrees. And so the total interior angles inside the hexagon add up to 720 degrees, and so each individual angle is equal to 720 degrees divided by 6 different angles, which is equal to 120 degrees. And so each interior angle in this regular hexagon is equal to 120 degrees, which we can label on our diagram. And so now we need to find the angle x. And so we can use the fact that angles around a point add up to 360 degrees in order to do this. And so the angles around this point are 135 degrees, 120 degrees, and x. And these all add up to 360 degrees. So we can say that x is equal to 360 take away brackets 135 plus 120, so we can say that x is equal to 105 degrees, which we can write down in our answer box. Now this question is worth 3 marks, so let's take a look at where these marks are allocated. Now the first mark is for finding the interior angles of the octagon and the hexagon. The second mark is for a process to find x by using the fact that angles around a point add up to 360 degrees. And the third and final mark is for getting the final correct answer that x is equal to 105 degrees, allowing us to get full marks in this question. In this question, we're given a Venn diagram, and in part A, we need to write down the numbers that are in the following sets. So in part AI, we have A, and then this U symbol means union. So we have A union B, and so union is any item that is in either set A or in set B. So A union B is kind of like saying A or B, so we need to find the numbers that are in set A or in set B. And so looking at our Venn diagram, we can see that these highlighted numbers are all in set A or they're in set B. And so we can say that the numbers in set A union B are 15, 12, 18, 10, 14, and 16. Now to part AII, we have A, and then we have this upside down U symbol, and B. And so this upside down U symbol is actually called intersection. And so A intersection B represents all the numbers that are in set A and are in set B, so the intersection between the two circles. And so taking a look at our diagram, we can see that these two numbers fall within set A and set B, and so the numbers that are in set A intersection B are 12 and 18. Now in part B, we're told that one of the numbers in the diagram is chosen at random, and so we need to find the probability that the number is in set A, and then we have this little dash symbol at the end. And so A dash is actually called the complement of A, and so the complement of set A means any number that is not in set A. And so to find the probability that the number is in the complement of set A, we need to find out how many numbers are not in set A. And so taking a look at our diagram, we can see that the highlighted numbers are not in set A. And so to find the probability, we need to find how many these are. So we can see that we have 7 highlighted numbers. And so this is out of a total of 10 numbers. And so we can say that the probability that the number is in the complement of set A is equal to 7 out of 10. Now this question is worth 4 marks, so let's take a look at where these marks are allocated. Now in part AI, we get 1 mark for the correct answer of 15, 12, 18, 10, 14 and 16. And in part AII, we get 1 mark for the correct answer of 12 and 18. Now part B is worth 2 marks, and so the first mark in part B is for listing the items that are not in A, and for saying that there are 7 of these items. And now the second mark is for getting the final correct answer of 7 out of 10, allowing us to get the full 4 marks needed in this question. In this question, we're told that on a farm, the number of cows and the number of sheep are in the ratio 6:5, and then we're told that the number of sheep and the number of pigs are in the ratio 2:1. The total number of cows, sheep, and pigs on the farm is 189, and we need to find out how many sheep there are on the farm. So let's start by representing this all together. So we have cows to sheep to pigs, and so we want to have a ratio of all 3 of these. We're told that the ratio of cows to sheep is 6:5, and that the ratio of sheep to pigs is 2:1. And so for us to be able to create a ratio of the number of cows to sheep to pigs, we need to make sure that we have a common ratio. And so we have 5 and 2 for the number of sheep, which means that the ratios are in 2 different scales. For them to be in the same scales, we need the ratio for the number of sheep to be equal. And so we can do this by using the lowest common multiple of 5 and 2. And so we want the ratio for the number of sheep to be 10. And so the number of cows to the number of sheep are in the ratio 6:5. Now to make this something to 10, we need to multiply both the 6 and the 5 by 2. And so 6 to 5 is the same as saying 12 to 10. And then we can do the same thing for the number of sheep to the number of pigs, which are in the ratio 2 to 1. And so for the ratio for the number of sheep to be equal to 10, we multiply both the 2 and the 1 by 5. And so 2 to 1 is the same as saying 10 to 5. And so we've now created a ratio that the number of cows to the number of sheep to the number of pigs is equal to 12 to 10 to 5. Now we're also told that the total number of cows, sheep and pigs on the farm is equal to 189. And so the ratio 12 to 10 to 5 gives a total of 189. Now let's take a look at how many parts are in 12 to 10 to 5. And so 12 plus 10 plus 5 is equal to 27. And so to find out how much one part is worth, we can do 189 divided by 27. And so we end up with 7. And so we can say that one part is equal to 7. We're asked to find out how many sheep there are on the farm. Now in the ratio, the number of sheep is represented by 10 parts. And we found out that each part is worth 189 divided by 27, which is equal to 7. And so we can say that the number of sheep is equal to 10 multiplied by 7, which is equal to 70. Now this question is worth 3 marks, so let's take a look at where these marks are allocated. The first mark is for finding the ratio of the number of cows to the number of sheep to the number of pigs, by ensuring that the original ratios are in the same scale. And so we found that the ratio of the number of cows to sheep to pigs is 12 to 10 to 5. Now the second mark is for using the fact that the total number of cows, sheep and pigs on the farm is 189, and so one part is equal to 189 divided by 27, which is equal to 7. And our third and final mark is for using this in order to find the number of sheep. And so we did 10 multiplied by 7, and so we found the correct answer, that the number of sheep on the farm is equal to 70. In this question, we're told that the arc ABC is a quarter of a circle with centre O and radius 4.8 centimeters. We're told that AC is a chord of the circle, and we need to work out the area of the shaded segment, giving our answer correct to 3 significant figures. Now to work out the area of the shaded segment, we can work out the area of the entire sector of the circle, and then work out the area of triangle OAC, and subtract the area of the triangle from the area of the sector. So let's start by finding the area of the sector of the circle. And so to find the area of the sector, we can do theta over 360 multiplied by pi r squared. We can see that the angle is equal to 90 degrees. And so in this case, theta is equal to 90. So 90 over 360 multiplied by pi times 4.8 squared. And so 90 over 360 multiplied by pi times 4.8 squared is equal to 5.76 pi. And it's always important to keep our answer in terms of pi until the very end, so that we retain the most accuracy. So now that we've found the area of the sector, we can find the area of triangle OAC. Now to find the area of triangle OAC, we'll do base times height divided by 2. We know that we have a base of 4.8 centimeters, and this is the radius of the circle. And so the height is the length OA. And so we can infer that the length OA is also equal to 4.8 centimeters, because OA is the radius of the circle. So we can say that the area is equal to 4.8 multiplied by 4.8, all divided by 2. And so the area of triangle OAC is equal to 11.52. Now to find the area of the shaded segments, we can do the area of the entire sector, which is 5.76 pi, take away the area of triangle OAC, which is 11.52, and so we get an answer of 6.575573 ... centimeters squared. Now we're told to give our answer correct to 3 significant figures, and so we can now say that the area of the shaded segment is equal to 6.58 centimeters squared, correct to 3 significant figures. Now this question is worth 3 marks, so let's take a look at where these marks are allocated. Now the first mark is for using the formula for the area of a sector in order to find that the area of sector OAC is equal to 5.76 pi centimetre squared. Now the second mark is for finding the area of triangle OAC in order to find the area of the shaded segments, and so we found that the area of triangle OAC is 11.52 centimetre squared. And that third and final mark is for subtracting the area of triangle OAC from the area of the sector in order to find the correct area of the shaded segments. And so we found that the area of the shaded segment is equal to 6.58 centimetre squared, correct to 3 significant figures, allowing us to get the third and final mark needed to get full marks on this question. In this question, we're told that Steve is asked to solve the equation 5 brackets x plus 2 is equal to 47, and we're given his working. We're told that Steve's answer is incorrect, and in part A, we need to find out which mistake he made. So let's trace through his working and see if we can spot the mistake. We start with 5 brackets x plus 2 is equal to 47, and every time we have brackets, we need to be really important to make sure that we multiply each term in the bracket. So now looking at what Steve did, when he expanded the brackets, he ended up with 5x plus 2, which is incorrect. We started off with 5 brackets x plus 2, and so when we multiply each term by 5, we end up with 5x plus 10. Now we can see that Steve did not do this, and he ended up with 5x plus 2 rather than 5x plus 10. And so we can say that the mistake Steve made was that he incorrectly expanded the brackets. Now in the second part of the question, we're told that Liz is asked to solve the equation 3x squared plus 8 is equal to 83, and we're given her working. And in part B, we need to explain what's wrong with Liz's answer. So let's take a look at her working. We start off with 3x squared plus 8 is equal to 83. She then moves the 8 over to the other side, and we have 3x squared is equal to 83 take away 8, which is equal to 75. So far, her working out is looking correct. She then divided both the left-hand side and the right-hand side by 3, and so we end up with x squared is equal to 25, which also looks correct. But now in the final line of working, Liz said that x is equal to 5, and this is what's wrong with Liz's answer. While she is correct that x is equal to 5, she didn't note that x can be equal to plus or minus 5, because when we square root a number, the solution can either be positive or negative. And so Liz's answer is wrong because she only obtained one solution rather than obtaining both solutions. And so by correctly spotting the mistakes in part A and part B, we've achieved the 2 marks needed to get full marks in this question. In this question, we're told that the functions f and g are such that fx is equal to 3 brackets x minus 4 and gx is equal to x over 5 plus 1. And in part A, we need to find the value of f10. And so where we have fx is equal to 3 brackets x minus 4, we're going to replace x with 10. And so we'll say f10 is equal to 3 brackets 10 minus 4. Now to simplify this further, 10 minus 4 is equal to 6. And so f10 is equal to 3 multiplied by 6, which is equal to 18. And so we can say that the value of f10 is equal to 18. Now in part B, we need to find the inverse function of g. And so we have gx is equal to x over 5 plus 1. Now to find the inverse function, we're going to say that y is equal to x over 5 plus 1. And now we want to make x the subject of this formula. Now we can start by moving the 1 over to the other side. And so we'll have y minus 1 is equal to x over 5. Now to make x the subject of the formula, we want to multiply both sides by 5. And so we have 5 brackets y minus 1 is equal to x. Now since we have x is equal to 5 brackets y minus 1, we can say that the inverse function of g can be written as g minus 1x is equal to 5 brackets x minus 1, which we can write down in our answer box below. Now in part C, we need to show that f of x is equal to 9x minus 48. And so this is a composite function. Let's start by finding f of x. So we know that f of x is equal to 3 brackets x minus 4. Now we need to find f of x. And so now we can say that f of 3x minus 4 is the same as saying 3 brackets 3x minus 4 take away 4. Well, now we need to simplify, and let's start by expanding these brackets. So we have 3 brackets, and then 3 multiplied by x minus 4 is the same as saying 3x minus 12, and then we have the minus 4 at the end. Now it looks a lot easier to solve. And so f of x is equal to 3 brackets 3x minus 12 minus 4, and so minus 12 minus 4 is equal to minus 16. Well, now we can expand these brackets and say that f of x is equal to 3 multiplied by 3x minus 16, and so multiplying each term separately, we have 3 multiplied by 3x, which is equal to 9x, and 3 multiplied by minus 16, which is equal to minus 48. And so we've now shown that f of x is equal to 9x minus 48. Now this question is worth 5 marks, so let's take a look at where these marks are allocated. Now in part A, we get 1 mark for getting the correct answer of 18. Now in part B, we get 1 mark for our workings out, and for saying that y is equal to x over 5 plus 1. And it needs to be clear to the examiner that we've been rearranging in order to find the inverse function of g. And then the second mark in part B is for getting the final correct answer of 5 brackets x minus 1, or alternatively, you could have expanded and written your answer as 5x minus 5. Either way is fine, and they'll both still get the mark. Now in part C, you get the first mark for a process to show that you're finding f of x. f of x is equal to 3 brackets x minus 4, and so we plug this entire value into our functions in the next part in order to find f of x. And the second mark in part C is for showing that f of x is in fact equal to 9x minus 48. And so we've now achieved the full 5 marks needed for this question. In this question, we're told that the population of a city increased by 5.2% for the year 2014. At the beginning of 2015, the population of the city was 1,560,000. Now Lynn assumes that the population will continue to increase at a constant rate of 5.2% each year. In part A, we need to use Lynn's assumption to estimate the population of the city at the beginning of 2017, giving our answer correct to 3 significant figures. Now since we're given the population at the beginning of 2015, and we're given the rate at which the population increases, we'll be able to estimate the population of the city at the beginning of 2017. Now we need to find out how many years are between 2015 and 2017, and so we can see that there are 2 years in between 2015 and 2017. Now we start with a population in 2015 of 1,560,000. Now for an increase of 5.2%, we can write this as a multiplier, and 5.2% written as a percentage increase multiplier is the same as saying 1.052. Now since this population increase is over a period of 2 years, and the rate is 5.2% each year, we can have 1.052 to the power of 2, because there are 2 years. And so we end up with 1,560,000 multiplied by 1.052 to the power of 2. And putting this into our calculator, we get an answer of 1,726,458.24. Now we're told to give our answer correct to 3 significant figures, and so rounding our answer, we can say that the population of the city at the beginning of 2017 is 1,730,000. Now in part B, we need to use Lynn's assumption to work out the year in which the population of the city will reach 2 million. And so we can use trial and error to do this. So let's start with 2019, for example. Now 2019 is 4 years away from 2015, and so we end up with the original population in 2015 of 1,560,000 multiplied by 1.052 to the power of 4, because there are 4 years between 2015 and 2019. And putting this into our calculator, we get an answer of 1,910,678.24. Now we can see that the population of the city still hasn't reached 2 million, and so let's take a look at estimating the population in 2020. We have 1,560,000 multiplied by 1.052 to the power of 5, because there are 5 years in between 2015 and 2020, and we get an answer of 2,010,033.509. And so we can see that the year in which the population of the city reaches 2 million is the year 2020, which we can write down in our answer box below. Now looking at the second part of part B, if Lynn's assumption about the rate of increase of the population is too low, how might this affect our answer to part BI? Now in part BI, we worked out the year in which the population of the city will reach 2 million. But if Lynn assumed that the rate of increase about the population is too low, that means the actual rate of increase is higher. And if the rate of increase is higher than Lynn's assumption, this means that the population will increase at a faster rate each year. And so if the population increases at a faster rate each year, the population of the city will likely reach 2 million before 2020, or at least earlier than it would have in our initial assumption. And so we can say that if the rate of population growth is higher, the population may exceed 2 million earlier. Now this question is worth 6 marks, so let's take a look at where these marks are allocated. The first mark is for using our rate of population growth and our initial value in 2015 in order to start the process to find the population at the beginning of 2017. The second mark is for finding the correct answer of 1,726,458.24. And the third mark is for correctly rounding to 3 significant figures and getting an answer of 1,730,000. Now in part B, the first mark is for a process to find when the population will exceed 2 million, and we use trial and error, and showed this in our working. And now the second mark is for getting the correct answer of 2020. Now in the second part of part B, we get 1 mark for correctly commenting on how the assumption will affect our answer. And so we said that if the rate of population growth is higher, the population may exceed 2 million earlier, allowing us to get the full 6 marks needed for this question. In this question, we're told that the cumulative frequency graphs below show information about the times taken by 100 male runners and 100 female runners to finish the London Marathon. And a male runner is chosen at random. In part A, we need to find an estimate for the probability that this runner took less than 4 hours to finish the London Marathon. Since the time on the graph is given in minutes, we need to convert 4 hours into minutes. And so multiplying 4 by 60, we can say that 4 hours is equal to 240 minutes. So we can highlight where 240 minutes is on our graph. To find the cumulative frequency at this point, we want to draw a line vertically upwards from the point at which the time is equal to 240. So now that we've drawn this line, we want to find the cumulative frequency for the time taken by male runners. So taking a look at the cumulative frequency graph for the male runners, we can draw a horizontal line from the point at which our vertical line meets the graph. So now based on our graph, we can see that at 240 minutes, the cumulative frequency for the male runners is equal to 42. Now this means that 42 runners took less than 4 hours to finish the London Marathon, but remember that this isn't our final answer. In part A, we need to find an estimate for the probability that this runner took less than 4 hours to finish the race. We're told that there are 100 male runners in total, and so the probability that this runner took less than 4 hours to finish the London Marathon is equal to 42 divided by 100, which is equal to 0.42. Now in part B, we're told to use medians and interquartile ranges to compare the distribution of the times taken by male runners with the distribution of the times taken by the female runners. So let's take another look at our graph. We want to find the median value for both male and female runners. Since there are 100 runners in total for both male and females, the median will be found at the point where the cumulative frequency is equal to 50. So looking at the y-axis, we can identify that the cumulative frequency is 50 at this point. So we can draw a horizontal line from this point until it meets both of the graphs. Now we can draw 2 vertical lines downwards at the point at which the blue line meets both of the graphs. Now using these lines, we can see that the median value for the male runners is equal to 252, and the median value for the female runners is equal to 276. Now we can work on finding the interquartile ranges for both the male runners and the female runners. And to do this, we need to find both the lower and upper quartiles. We'll start by finding the lower quartile. Now the lower quartile will be found at the point at which the cumulative frequency is equal to 25, which we can identify to be over here. So doing the same thing as we did for the median, we can draw a horizontal line at this point. Now we can draw 2 vertical lines downwards the same way we did for the median. So we can see that the lower quartile for the male runners is equal to 213, and the lower quartile for the female runners is equal to 243. And finally, we can find the upper quartile for both the male runners and the female runners, and so the upper quartile will be found at the point where the cumulative frequency is equal to 75. Now 75 is located over here. And in the same way that we did the median and the lower quartile, we can draw a horizontal line at this point. Now drawing the two vertical lines downwards, we can identify that the upper quartile for the male runners is equal to 288, and the upper quartile for the female runners is equal to 312. So let's write down what we've found so far. For the male runners, we've found that the median is equal to 252. We found that the lower quartile for the male runners is equal to 213, and the upper quartile for the male runners is equal to 288. And to find the interquartile range for the male runners, we do the upper quartile, take away the lower quartile, which in this case will give us an answer of 75. Now let's do the same for the female runners. We found that the median value for the female runners is equal to 276. We found that the lower quartile for the female runners is equal to 243, and that the upper quartile for the female runners is equal to 312. And so we've found that the interquartile range for the female runners is equal to 312 take away 243, which is equal to 69. So now that we've found out this information, we can answer part B. So we can start by writing down the median values and the interquartile ranges that we found for both the male runners and the female runners. Now based on this information, we can make some comparisons between the times taken by the male runners and the times taken by the female runners. Now since the median value for the female runners is greater than the median value for the male runners, we can say that on average the time taken by females is greater than the time taken by males. Now the interquartile ranges for both the male runners and the female runners are quite similar, and so we can say that based on the interquartile ranges, the spread of times for both the male runners and the female runners is about the same. Now this question is worth 6 marks in total, so let's take a look at where these marks are allocated. In part A, we get the first mark for using the graph at the point where the time is equal to 240 minutes, in order to find the cumulative frequency at this point. Now the second mark is for finding the estimate for the probability that the runner took less than 4 hours to finish the London Marathon by doing 42 divided by 100 and for getting a final answer of 0.42. Now in part B, we get 1 mark for identifying the median value for the male and female runners. We get the second mark for identifying the interquartile range for the male and female runners. We get the third mark for a statement saying that on average the females took longer than the males. And we get the fourth mark for identifying that spread of times for both male and female runners is roughly the same. And so we've now achieved the full 6 marks needed in this question. In this question, we're told that Marie has 25 cards. Each card has a different symbol on it. Marie gives 1 card to Shelley and 1 card to Pauline, and we're asked to find out how many different ways Marie can do this. And so we start off with 25 cards. And so when she gives 1 card to Shelley, there'll be a choice of 25 cards. Now when she gives 1 card to Pauline, there'll be 1 less card to choose from, and so there'll be 24 choices. And so we've now established that there are 25 options when she gives the card to Shelley, and then 24 options remaining when she gives the card to Pauline. And so to find out how many different ways Marie can give 1 card to Shelley and 1 to Pauline, we have to do 25 multiplied by 24. And so 25 multiplied by 24 will give us an answer of 600. Now in part B, we're told that there are 12 boys and 10 girls in David's class. Now David is going to pick 3 different students from his class and write their names in a list in order. The order will be boy, boy, or girl, boy, girl, and we need to find out how many different lists that David can write. So let's start with boy, girl, boy. So we start off with 12 boys. Then we have 10 girls. And now there are 11 boys remaining, because 1 has already been chosen at the beginning. So there are 11 boys left to choose from. And so like we did before, to find the number of different combinations for this, we do 12 multiplied by 10 multiplied by 11, which will give us an answer of 1,320. Now let's do the girl-boy-girl combination. So we start off with 10 girls. Then we have 12 boys. And then there are 9 girls remaining, since we've already chosen one at the beginning. And so multiplying 12 and 10 and 9 together, we'll get an answer of 1,080. So now we've found out that for the boy-girl-boy order, David can make 1,320 lists. And for the girl-boy-girl order, David can make 1,080 lists. Now to find out how many lists David can write in total, we can do 1,320 plus 1,080, and we'll get an answer of 2,400, which we can write down in our answer box below. Now this question is worth 5 marks, so let's take a look at where these marks are allocated. The first mark in part A is for a process to find the number of combinations by doing 25 multiplied by 24. And the second mark in part A is for getting the final correct answer of 600. In part B, we get 1 mark for a process to find the number of different lists for the boy-girl-boy order and for finding the number of different lists for the girl-boy-girl order. The second mark is for a process to find the total number of lists by adding these two numbers together. And finally, the third mark is for getting the correct final answer of 2,400. And so we've now achieved the 5 marks needed to get full marks in this question. In this question, we're told that the number of slugs in a garden t days from now is pt, where p0 is equal to 100 and pt plus 1 is equal to 1.06 multiplied by pt. We need to work out the number of slugs in the garden 3 days from now. And so let's identify what we're looking for. If t represents the number of days, and we want to find the number of slugs in the garden 3 days from now, we're looking to find p3. So we have p0 is equal to 100, and we're given the formula to find the next term in the iteration. So let's start by finding p1. p1 is equal to 1.06 multiplied by p0, and so 1.06 multiplied by 100 is equal to 106. Now let's find p2. p2 is equal to 1.06 multiplied by p1, and p1 is equal to 106. And so p2 is equal to 112.36. Now finally, to find p3, we'll do 1.06 multiplied by p2, so multiplied by 112.36, and so we'll get an answer of 119.1016. And so rounding to the nearest whole, we can say that the number of slugs in the garden 3 days from now is approximately 119, which we can write down in our answer box below. This question is worth 3 marks, so let's take a look at where these marks are allocated. Now the first mark is for starting off the process to find p1 by doing 1.06 multiplied by 100 to get an answer of 106. Now the second mark is for continuing the process in order to find p3. And the third mark is for getting the final correct answer of 119, allowing us to get the full 3 marks needed in this question. In this question, we're told that d is directly proportional to the cube of n. Mary says that when n is doubled, the value of d is multiplied by 6. Mary is incorrect, and we need to explain why. So let's add some numbers to this. When something's doubled, we know that it's multiplied by 2. And so the cube of a number means something, which we'll call x, to the power of 3. So now that we have some numbers in this, let's find out why Mary is wrong. So if d is directly proportional to the cube of n, when d is multiplied by 2, n should be multiplied by 2 to the power of 3. Mary says that when n is multiplied by 2, the value of d is multiplied by 6. But we know that's not true, because 2 to the power of 3 is equal to 8. And so when n is doubled, the value of d should be multiplied by 8, not by 6. And so we can write this down below. And so with this explanation, we've achieved the 1 mark needed to get full marks in this question. In this question, we're told that Carol runs in a race, and we're given a graph which shows her speed in meters per second, t seconds after the start of the race. We have speed on the y-axis and time on the x-axis. And in part A, we need to calculate an estimate for the gradient of the graph when t is equal to 4. This graph is a curve, and when we want to find the gradient at a given point, we need to draw a tangent to the line which passes through the given point. And so we have t is equal to 4. So we want to draw a tangent to the curve at this point over here. And a tangent to the curve is a straight line that's as close to the shape of the curve as possible. So now that we've drawn our tangent to the curve at the point t is equal to 4, we can find the gradient of the tangent in order to find an estimate for the gradient of the graph when t is equal to 4. And so to find the gradient, we want to do the change in y divided by the change in x, and we can draw a gradient triangle to help us do this. Now that we've drawn our gradient triangle, let's take a look at the change in y and the change in x. So this point over here has a y value of 8.8, and this point over here has a y value of 7. Now for the x values, this point over here has an x value of 4.8, and this point has a value of 3.2. Now to find the change in y divided by the change in x, we can do 8.8 take away 7 divided by 4.8 take away 3.2. So plugging these values into our calculator, we'll get an answer that the gradient is equal to 1.125. As for rounding this to one decimal place, we can say that the gradient is equal to 1.1. In part B, we were asked to describe fully what our answer to part A represents. Now let's take a look back at our graph. And so our answer to part A is the gradient, which is the change in y, divided by the change in x, which is the change in speed divided by the change in time. And so the change in speed divided by the change in time is equal to the acceleration. And so looking at part B, we can say that part A represents the acceleration at the point where t equals 4, which means the acceleration 4 seconds after the start of the race. In part C, we need to explain why our answer to part A is only an estimate. And this is because we drew a tangent. Since we drew a tangent to the line, we can only ever estimate the gradient of our graph. And so depending on how accurate our tangent actually is, we'll never know which gradient is actually the true value. And so we can say that our answer to part A is only an estimate because it depends on the accuracy of constructing the tangent. Now this question is worth 6 marks, so let's take a look at where these marks are allocated. And so in part A, we get the first mark for drawing a tangent to the curve at the point t is equal to 4. We get the second mark for a process to find the gradient by doing the change in y divided by the change in x. And the third mark in part A for getting an answer in the range 1.0 to 1.3, and our answer of 1.1 falls within this range, and so we get the last mark in part A. In part B, we get 1 mark for saying that part A represents the acceleration, and the second mark for saying that this acceleration is at the point 4 seconds after the start of the race. And in part C, we get the 1 mark for correctly explaining that our answer to part A is only an estimate because it depends on the accuracy of the tangent. And so we've now achieved the 6 marks needed to achieve full marks in this question. In this question, we're asked to find the value of the fifth root of 3.2 times 10 to the power of 11. So what we can do is plug this entire expression into our calculator. And so when we find the fifth root, it might be useful to put the 3.2 times 10 to the power of 11 all in brackets, so that the calculator is extremely sure that it's finding the fifth root of the whole expression. And so when we put this into our calculator, we'll get an answer of 200. Now in the second part of the question, we need to find the value of 10 to the power of 3/4, giving our answer correct to one decimal place. And so when we put this into our calculator, we can see that 10 to the power of 3/4 is equal to 5.6234132 ... and our answer correct to one decimal place would be equal to 5.6. And so in this question, we get each of the 2 marks available for getting both parts of the question correct. In this question, we're given a right angled triangle, and we're told that A is equal to 8.3 centimeters, correct to the nearest millimeter, and that B is 6.1 centimeters, correct to the nearest millimeter. We need to calculate the upper bound for C, and we must show our working. So we can start by finding the upper and lower bounds for both A and B. So we'll start with A, which is 8.3 centimeters. Now if this is correct to the nearest millimeter, the upper bound is half a millimeter more than 8.3, and the lower bound is half a millimeter less than 8.3. And so we can say that the upper bound is 8.35, and that the lower bound is 8.25. And so we can do the exact same thing with B. We have 6.1, and so we can say the upper bound is 6.15, and that the lower bound is 6.05. So when we have questions that involve bounds, it's always really useful to draw a quick diagram like the one we have here, with arrows showing the upper bound and lower bound, so that when we need to use them in a question, it's really easy to just pick out what we need. Now to calculate the upper bound for C, let's first figure out how we find C. We have a right angled triangle with 2 known sides and 1 unknown, which means we can use Pythagoras to calculate this. So A is a hypotenuse, and so we can say that B squared plus C squared is equal to the hypotenuse squared. So we can say that B squared plus C squared equals A squared. And so taking the B squared over to the other side, we can say C squared is equal to A squared minus B squared, and so C is equal to root A squared minus B squared. So now we want to find the upper bound for C. And so when we have an upper bound for a subtraction calculation, we'll do the upper bound, take away the lower bound, which will give us the largest possible answer for C. And so this is because when we start with the upper bound and we take away the lower bound, we're taking away the smallest possible number. And so our final answer ends up being the largest possible answer. If we had upper bound, take away upper bound, we'd be taking more away from the original value, and so we'd end up with a value that's less than the upper bound, take away the lower bound. And since we're trying to find the upper bound, we want to have the highest possible value for C. And so using the fact that the upper bound for C would be equal to the upper bound of A, take away the lower bound of B, we can say that C is equal to root. So A squared, we'll use the upper bound, so 8.35 squared, take away the lower bound for B, which is 6.05 squared. And so when we plug this into our calculator, we'll find that C is equal to 5.754997 ... And rounding our answer correct to 2 significant figures, we can say that C is equal to 5.8 centimeters. Now this question is worth 4 marks, so let's take a look at where these marks are allocated. We get the first mark for finding the upper and lower bounds of 8.3 and 6.1. We get the second mark for deciding the correct bounds to use, and so we said that the upper bound for subtraction will be the upper bound of A, take away the lower bound of B. The third mark is for identifying that we need to use Pythagoras, and to find that C is equal to root A squared minus B squared. And the final mark is for plugging in the correct bounds and the correct values in order to find the final answer that C is equal to 5.8 centimeters, allowing us to get the 4 marks needed to get full marks in this question. In this question, we need to simplify fully root A plus root 4b multiplied by root A minus 2 root b. And so the first thing that we can notice is that root 4b is equal to root 4 multiplied by b, which is the same as root 4 multiplied by root b, which is the same as 2 root b. And so we can rewrite a quadratic. We can say that root A plus root 4b multiplied by root a minus 2 root b is the same as saying root a plus 2 root b multiplied by root a minus 2 root b. And so we can see now that we have a difference of 2 squares. So let's start by expanding these double brackets. And so we'll start with root a multiplied by root a, which is equal to a. We then have root a multiplied by minus 2 root b, which is equal to minus 2 root b root a. We then have plus 2 root b multiplied by root a, and so that's equal to plus 2 root b root a. And then finally we have plus 2 root b multiplied by minus 2 root b, which is equal to minus 4b. And so we can see that difference of 2 squares means that the minus 2 root b root a plus 2 root b root a cancels out. And so we end up with a final answer of a minus 4b, which we can write down in our answer box below. Now this question is worth 3 marks, so let's take a look at where these marks are allocated. The first mark is for identifying that root 4b is equal to 2 root b. The second mark is for a process to expand the double brackets after having identified that this quadratic is a difference of 2 squares. And the third mark is for simplifying and getting a final correct answer of a minus 4b, allowing us to get the full 3 marks needed for this question. In this question, we're asked to sketch the graph of y equals cos x for the values of x between 0 and 360. And so the graph of cos x is something that we're expected to have memorized. We know that the maximum and minimum values of cos x are 1 and minus 1. So cos x, when x equals 0, starts at the y value of 1. And then we go through 90, and we cross 180 at minus 1, then 270, and then back up to 360. And it's really important that we label the coordinates on our sketch. So we have 0, 1, we then have 90, 0, 180, minus 1, 270, 0, and finally we have 360, 1. Now this is a graph that we should have memorized, but since this is a calculator paper, we can always double check using our calculator. But you should never be reliant on checking on your calculator, because this question could come up in paper 1. And paper 1 is a non-calculator paper, and so you wouldn't be able to check your answer. But since this is paper 2, we can just double check. And so in our calculator, we can put cos 0, which is equal to 1. So we got the point 0, 1 correct. And then we can try cos 90, and putting that into our calculator, we get an answer that cos 90 is equal to 0. Then we have cos 180, and after putting that into our calculator, that's equal to minus 1. And we'll do for 270, so cos 270 is equal to 0, and then finally, cos 360 is equal to 1. And so using these values, we can see that we've correctly sketched the graph of y equals cos x for the values of x between 0 and 360 degrees. Now in part B, we're given the graph of y equals f of x. And in part BI, we need to draw the graph of y equals 2fx. And so the graph of y equals 2fx is a vertical stretch by a scale factor of 2. So we're going to draw the graph of y equals 2f of x in purple, so that we can see the difference between the original in black. So let's start by labelling the points. Here we have minus 3, 1, minus 2, 1, 0, 3, 2, 1, and finally we have 3, 1. So if we have a vertical stretch by a scale factor of 2, we can multiply all the y coordinates by 2, but leave the x coordinates the way they are. So we'll start with minus 3, 1. We'll leave the x coordinate as minus 3, but then the y coordinate of 1 gets multiplied by 2. And so we can change this to minus 3, 2. We can do the same for the next point. Minus 2, 1, minus 2 stay the same, the y coordinate of 1 gets multiplied by 2, and so we have minus 2, 2. Then for 0, 3, the 0 stay the same, the 3 gets multiplied by 2, and so we have a new coordinate of 0, 6. Then we have 2, 1. the x-coordinate of 2 stays the same, and then the y-coordinate of 1 gets multiplied by 2 and becomes 2, 2. And finally, we have 3, 1, the x-coordinate of 3 remains unchanged, and then we have the y-coordinate of 1, which gets multiplied by 2 to become 2, and so the final coordinate is equal to 3, 2. And then we can join these points together. And so now that we've stretched our graph vertically by a scale factor of 2, we can label this correctly as y equals 2f of x. Now in the second part of part B, we need to draw the graph of y equals f of x minus 3. And so when we have a change inside the bracket, it's the opposite of what we'd expect. And so instead of shifting the x-coordinates by minus 3, we'll instead shift it by plus 3. And so the graph of y equals f of x minus 3 is a translation by a vector of 3, 0. And so let's label all the original points again. We'll start with the point minus 3, 1. And to shift this by a vector of 3, 0, we need to add 3 to the x-coordinate and do nothing to the y-coordinate. We have an x-coordinate of minus 3. So minus 3 add 3 is equal to 0. Now the y-coordinate of 1 remains unchanged, so our new point is equal to 0, 1. We then have the point minus 2, 1. And so to add 3 to our x-coordinate, we have minus 2 plus 3, which is equal to 1. And so the y-coordinate remains unchanged, which means our translated coordinate is equal to 1, 1. Then we have the point 0, 3. And so we have an x-coordinate of 0. When we add 3 to this, we have an x-coordinate of 3. Now the y-coordinate remains unchanged, so our new point is equal to 3, 3. Then we have the point 2, 1. So when we add 3 to the x-coordinate, we have 2 plus 3 is equal to 5. The y-coordinate of 1 remains unchanged, and so our translated point is equal to 5, 1. And finally, we have the point 3, 1. So translating this by a vector of 3, 0, we add 3 to the x-coordinate, and so our new x-coordinate will be 6. The y-coordinate of 1 remains unchanged, and so our translated coordinates is equal to 6, 1. Now we can join up these points. And so we've now correctly drawn the graph of y equals f of x minus 3. Now this question is worth 4 marks, so let's take a look at where these marks are allocated. In part A, we get 1 mark for drawing the correct shape of the graph of y equals cos x. And the second mark in part A is for correctly labelling all of the points. Now in part B, the first part of part B is worth 1 mark, and we get this 1 mark by correctly drawing the graph of y is equal to 2f of x. And in the second part of part B, we get 1 mark for correctly drawing the graph of y is equal to f of x minus 3. And so we've now achieved the full 4 marks needed to get full marks in this question. In this question, we're told that PQRST is a regular pentagon. R, U, and T are points on a circle, centre O. QR and PT are tangents to the circle, and RSU is a straight line. We need to prove that the line ST is equal to the line UT. Now since we're told that PQRST is a regular pentagon, we can find out the size of each interior angle, because each interior angle in a regular pentagon would be equal. So we'll start by finding the exterior angles. To find the exterior angles in a regular polygon, we do 360 divided by the number of sides in that shape. A pentagon has 5 sides, so we do 360 divided by 5, and we get an answer of 72 degrees. And so to now find the interior angles, we would do 180 take away 72, which would leave us with 108 degrees. And so we've now found that each interior angle in a regular pentagon is equal to 108 degrees. And so we can begin to label this in our diagram. So it's always a good idea to label as many angles as you can in your diagram. But you don't want to label too many angles or else it can get quite messy. So for now, we'll label 2 of the interior angles in the pentagon as 108 degrees. We know that the other 3 angles in the pentagon are also 108 degrees, but we won't write these down for now. Now taking a look at our diagram, we have centre O. Points R and T lie on the circumference of the circle. We know that the distance between the centre and any point on the circumference is a radius. And so we can say that the line OR is a radius and the line OT is a radius. We also know that QR and PT are tangents to the circle, and so the angle between a radius and a tangent is always equal to 90 degrees, and so we can label these right angles on our diagram. Now an important angle that would help us to prove that ST equals UT would be the angle ROT, which we'll label as an empty angle in our diagram for now. Now to begin to find angle ROT, we need to know the number that all angles in a pentagon add up to. So looking at a regular pentagon, if each interior angle is equal to 108 degrees, the total angles in a pentagon would be equal to 108 multiplied by 5, which is equal to 540 degrees. And this isn't just for a regular pentagon. The angles inside any pentagon, whether regular or not, will always add up to 540 degrees. So now outlining RQPTO, we can see that this shape is a pentagon. It's not regular, but we know that all angles inside this shape add up to 540 degrees. And so we can use this fact in order to find angle ROT. Now like we said earlier, each interior angle in a regular pentagon is equal to 108 degrees. The angle QPT is inside the regular pentagon, and so this is also equal to 108 degrees. So now to find ROT, we can do 540 take away 90 plus 108 plus 108 plus 90, which would leave us an answer of 144 degrees, which we can label in our diagram. Now we can find the angle RUT. Using our knowledge of circle theorems, we know that the angle at the centre is twice the angle at the circumference. The angle at the centre is 144 degrees, which we just calculated, and so we can say that the angle at the circumference is 144 divided by 2, which is equal to 72 degrees. Now that we've found angle TUS, we can work on finding angle TSU. So given that angles on a straight line add up to 180 degrees, we can say that angle TSU is equal to 180 take away 108, which is equal to 72 degrees. So now that we've found angle TSU and angle TUS, we've already proven that ST is equal to UT, and so let's take a look at why. Let's outline the triangle TSU in orange. So looking at this triangle, we can see that angle TSU is equal to angle TUS, and so the base angles of this triangle are equal. We can then correctly identify that triangle TSU is an isosceles triangle. So if triangle TSU is an isosceles triangle, we can say that line ST is equal to line UT. And so we've written this down in our answer below. We said that the base angles in an isosceles triangle are equal. Given that angle TUS is equal to angle TSU, we can say that triangle TSU is isosceles, and therefore line ST is equal to UT. Now this question is worth 5 marks, so let's take a look at where these marks are allocated. We get the first mark for a method to find the interior or the exterior angle of the regular pentagon. We get the second mark for using the angle between the tangent and the radius, and for correctly identifying this as 90 degrees. We get the third mark for a method to find the angle ROT, and so we did this by using the fact that the total angles inside a pentagon add up to 540 degrees, and so we found the angle ROT is equal to 144 degrees. We get the fourth mark for a method to find angle RUT, with a reason. So we said the angle RUT is equal to 72 degrees, and our reason is that the angle at the centre is twice the angle at the circumference, and so we did this using our knowledge of circle theorems. And finally, that fifth mark is for a conclusive statement, saying that line ST is equal to line UT. We said that ST equals UT because base angles in an isosceles triangle are equal. This means that triangle TSU is isosceles, and so line ST is equal to line UT. allowing us to get the fifth and final mark needed to get full marks in this question. In this question, we're told that the ratio of 2x minus 1 to x minus 4 is equal to the ratio of 16x plus 1 to 2x minus 1. We need to find the possible values of x. Now we can start by writing the ratios as a fraction. So we can say that 2x minus 1 over x minus 4 is equal to 16x plus 1 over 2x minus 1. Now let's cross multiply. We have 2x minus 1 multiplied by 2x minus 1 is equal to 16x plus 1 multiplied by x minus 4. We have two sets of double brackets, so let's begin to expand. 2x multiplied by 2x is equal to 4x squared. Then we have 2x multiplied by minus 1, which is equal to minus 2x. We then have minus 1 multiplied by 2x, which is equal to minus 2x. Finally, we have minus 1 multiplied by minus 1, which is equal to plus 1. Now moving on to the next set of double brackets, we have 16x multiplied by x, which is equal to 16x squared. We then have 16x multiplied by minus 4, which is equal to minus 64x. Then we have 1 multiplied by x, which is equal to plus x. And finally, we have 1 multiplied by minus 4, which is equal to minus 4. Now let's simplify both sides. 4x squared minus 2x plus 1 can be written as 4x squared minus 4x plus 1. 16x squared minus 64x plus x minus 4 can also be written as 16x squared minus 63x minus 4. Now in order to solve for x, we want to create a quadratic equation equal to 0. And so to do this, we can move this entire expression over to the right hand side. And so we'll end up with 16x squared minus 63x minus 4, and then we have minus 4x squared plus 4x minus 1, all equal to 0. Now simplify. 16x squared minus 4x squared will simplify into 12x squared. Minus 63x plus 4x will simplify into minus 59x. And then minus 4 minus 1 will simplify to minus 5. And so we end up with 12x squared minus 59x minus 5 is equal to 0. To solve this quadratic equation, we need to factorize. And so 12x squared minus 59x minus 5 equals 0 can be factorized into two double brackets, where 12x plus 1 multiplied by x minus 5 is equal to 0. So now we can use this to find our two possible values of x. When 12x plus 1 is equal to 0, 12x is equal to minus 1, and so x is equal to minus 1 over 12. And then when x minus 5 is equal to 0, moving the minus 5 over to the other side, x is equal to 5. So we've now correctly found our two solutions. We found that x is equal to 5 and that x is equal to minus 1 over 12. Now this question is worth 5 marks, so let's take a look at where these marks are allocated. We get the first mark for writing the ratios as an equation by cross-multiplying. And so we said that 2x minus 1 multiplied by 2x minus 1 is equal to 16x plus 1 multiplied by x minus 4. We get the second mark for rearranging and for getting 4x squared minus 4x plus 1 is equal to 16x squared minus 63x minus 4. The third mark is for a process to rearrange this into a quadratic equation equal to 0. And so we ended up with 12x squared minus 59x minus 5 is equal to 0. The fourth mark is for a process to solve this, and so by factorizing, we've shown that we're trying to solve the quadratic equation. And so we get the fourth mark for writing this as 12x plus 1 multiplied by x minus 5. And finally, we get the fifth and final mark for getting the correct two values of x. We said that x is equal to minus 1 over 12 and that x is equal to 5. Now these two values are correct, allowing us to get the fifth and final mark needed to get full marks in this question.